This video is on adding and subtracting rational expressions. Adding and subtracting rational expressions is very similar to adding and subtracting fractions. You must have a common denominator. Let's take a look at a couple examples here. Our first example is 17n plus 4 over 15n minus 5 minus 2n minus 6 over 15n minus 5. This one's nice. It has a common denominator. I don't have to worry about that. So what I'm going to have is 17n plus 4 minus, be careful, the whole quantity, 2n minus 6, all over the one denominator. So what that's going to give me is 17n plus 4, and I will subtract each term in my second polynomial over my common denominator. And now I want to combine like terms on top. 15n plus 10 over 15n minus 5. And remember, as we spoke in previous videos, that you cannot cancel these 15n's because they are not factors of both the numerator and the denominator. But I'm thinking I might have a common factor because I'm seeing a lot of 5's in there. So let's go ahead and factor a 5 out of the numerator. So that's going to give me 3n plus 2. And let's factor a 5 out of the denominator. That's going to give me 3n minus 1. And now I can cancel those 5's. And my result is going to be 3n plus 2 over 3n minus 1. Second example here is 3x minus 4, 3x divided by x minus 4 plus 6x over 4 minus x. Notice my denominators are not exactly the same. So 4 minus x is the same as negative x plus 4. And if I were to factor a negative 1 out of that, I would end up with an x minus 4. So I'm going to go ahead and rewrite this as 3x over x minus 4 plus 6x over a negative 1 times x minus 4. And this is actually a little bit of a unique situation here. Since my denominator is being multiplied by a negative 1, I can really just take that and move that up to the numerator. Because with a negative 1, it doesn't matter if the negative's on the top or on the bottom of the fraction. So that's going to give me, combining terms across the top, 3x minus 6x is going to give me a negative 3x. And I have my common denominator of x minus 4. And our last example here has two completely different denominators. I have a over a plus 4 plus 6 over a plus 2. So those are two completely different ones. I can't just like add 2 to this one to make it a 4 because that doesn't work with fractions. You have to multiply to get a common denominator. So my common denominator is actually going to be, I'll go ahead and write it here, it's actually going to be the product a plus 4 and a plus 2. Okay, so I need to multiply my first fraction by an a plus 2, top and bottom. And my second fraction, I need to multiply it by an a plus 4, top and bottom. Okay, so now I have a common denominator for both of those. So that's going to give me a times a plus 2 plus 6 times a plus 4 all over my common denominator of a plus 2, a plus 4. Now the temptation right here is to go ahead and cancel those a plus 2's and cancel those a plus 4's, but you can't do that because you've actually got one term here that's being added to another term. We can't cancel things that are multiplied. We can only cancel factors, and factors are things that are multiplied. So don't cancel. And actually, if you did try to cancel at this point, you'd kind of end up back where you started, which is not where you want to be. So let's just go ahead and distribute on the top. A squared plus 2a plus 6a plus 24 over a plus 2 times a plus 4. And all that's left is to combine like terms. A squared plus 8a plus 24 over a plus 2 times a plus 4. The only other thing I might check with this one is to see if my trinomial in the numerator can be factored, which I don't believe it can. If it could, you might want to factor it and see if one of those factors can cancel with a factor in the denominator, but in this case, no, and that's my final answer. So I have a couple practice problems here I'd like you to try on your own. So go ahead and stop the video and do these in your math journal. Okay, let's take a look at these two practice problems. So for the first one here, I have 14y over 9 minus y, and my other one is 2y over y minus 9. So I think I'd like to turn this 9 minus y. Remember what we can do there is 9 minus y is equal to negative y plus 9. Factor out a negative 1, and I can get my y minus 9. So I'll do 14y over negative 1 times y minus 9 minus 2y over y minus 9. The unique thing about this negative 1 is I can go ahead and put that on the top of the fraction. So I will have negative 14y minus 2y gives me a negative 16y over y minus 9. And that's my final answer. And then my last example here is 7 over 4x plus 8 minus x over x plus 2. And what I'm noticing about the 4 minus 8 is I can factor that into 4 times x plus 2, which is really nice because x plus 2, one of those factors, x plus 2, is actually the denominator of my second rational expression. So my common denominator is going to be 4 times the quantity x plus 2, which means that this fraction needs to be multiplied by a 4 top and bottom. So that's going to give me 7 minus 4x, 4 times x, over 4 times x plus 2. And I can't factor the numerator, so that's my final answer right there. So in this video, we took a look at how to add and subtract rational expressions, which is a lot like adding and subtracting fractions in that you have to have a common denominator before you can combine the numerators.